Sorry about that. Functions. Function, a relationship between the input and the output. There is exactly one output for each input. That means the x, or the input, doesn't repeat. So, determine whether each relation is a function. So if I look at this on mapping, the way you tell is if I look at this, do you see how 4 only goes to one number? Or sorry, -4. -2 goes to one number. 2 goes to one number. 5 goes to one number. That means that yes, this is a function. All domain values have exactly one range value okay, that's not stated right. That's weird. Okay. 2 is going to two different numbers. It can't go to two different numbers. So 2 has two different, and that's the important word, two different range values. Or two output. Okay, I look over here. We have 2, 4, 8, 4. Up, 4 goes to two different things. So this is not a function. 4 goes to, did I just write that as TWO? Oh my goodness, that is embarrassing. Oh no, that was the right 2 for that. Sorry. Goes to two different range values. And if you want to put output values, that's okay too. If you want to put Y values, that's fine also. Okay, so we're going to come down here. So if I look at this one, 2, 3, 5, 8, and each one of them has one arrow going out. Okay, so that is a function. 0 goes to 8, 0 goes to -1, not a function. Negative, gotta have it all. -4, -2, up, I have two -2s, so not, so the only one was the first one. Okay, so next, need to make that smaller, but it's having issues. Okay, so long jump. 5 schools are competing in the long jump portion of the track meet. The distances for of the team players with the best jump on each team are as follows. Team 1, 20.6 feet. Team 2, 21.5 feet. Team 3, 20.9 feet. Team 4, 19.4 feet. And Team 5, 20.2 feet. So, teams, and this is distances, and that's in feet. Okay, so team 1, 2, 3, 4, 5. Team 1 goes to 20.6 feet, 21.5 feet, 20.9 feet, 19.4 feet, and 20.2 feet. So the first thing it's asking us is what is the domain? So domain are the teams. Okay, so 1, 2, 3, 4, 5. The range, 19.4, 20.2, 20.9, if I'm going to have enough space. Oh, did I forget 20.6? 20.6, 20.9, 21.5. Is it a function? Yes, because each one of the teams only has one. Yes, it's a function. Each team only has one distance. Okay, so here we have the height. Bailey recorded the heights of 5 of her friends. The heights in inches are as following. Okay, what's the domain? The domain are the people's names. So this would be like an ordered pair. So Hunter, Ling, Ella, Omar, and Alma. Oops, I forgot the A on Alma. This is my domain. My range would be the numbers. So 62, 65, 66, 67. And if you notice, 66 is repeated, but we only write it down once when we're in the range. Is it a function? Yes, it's a function. Yes, it is. The friends only have one height per person. Now, the next one, is it a function? Well, it's graphed right here. Is that a function? Well, no matter what value I put in for x, the y value is only going to have one answer. I'm also going to explain that if it is a line except x equals a number, then it is a function. Okay, so that means the exponents of x and y are 1. See how this exponent right here is a 1 and this exponent right here is a 1? Automatically is going to be a line. Is it a function? Yes. Oh, I never talked about the vertical line test. Okay. So before I do that, so there's this thing called the vertical line test. Vertical line test means that no matter where I draw a vertical line in this right here, no matter where I draw this vertical line, and those are horrible lines, if every time I draw a vertical line, it only hits it one time, then it is a function. So the vertical line test each time you draw a vertical line, it can only pass through the relation 1 point at a time. And the reason I say relation is because not always will it be a line. Okay? So if I did this one, I drew a line. So this is yes. Okay, I'm going to change the color for a second. Now, if I drew one that looked like this, and I had these two like this, and I drew a vertical line, that hits 2 points at the same time. So no, this is not a function. Okay, so now let's go back to this. The relation passes the vertical line test, then yes, that is. An element of the domain is paired with two elements. So if I have something in the domain and it goes to 2, and that same number goes to another number, no. The vertical line passes through more than 1 point at a time. Yeah, it can't do that. Per this right here, it cannot do that. The domain represents each student in class, while the range represents the age of each student. Because your one person isn't going to be the same age at any point in time, then yes. The domain represents the number of a day in May, and the range represents the high temperature of the day. So once it gets to that high temperature, it's done. It's not going to have two different high temperatures. Remember how I said the exponents have to be 1? This exponent is not 1. This is not a function. Okay, so this next part, function notation. It is the way of writing this equation. Okay, so y and f of x are the same thing. What's going to be happening is we're going to see f of x, and you're going to see it like this. All this does right here is it tells you what x is. It does not mean multiplication. Misspelling of that word, multiplication. It does not mean multiplication. All it's telling you is what you're plugging in for the x value. That's all it means. So over here, if I give you this function right here, all we're going to do is take this 4 right here and plug it in. So f of 4 is going to equal negative 2 times 4 plus 9. So f of 4 is going to be negative 8 plus 9. So f of 4 is equal to 1. Now, it's not actually asking you for what f of 4 is. If you notice, it's asking you what f of 4 plus 3 is. So, what we have to do is we have to take f of 4 and we have to add 3. We just found that f of 4 is this number right here. So I'm going to replace it. So my answer to this question is the number 4. So all we've done is found what plugging in the number 4 would get you. That's all you're doing. So coming over here. Okay, so I have to write it negative f of x equals negative 2x plus 9. Is that right? Yeah. Okay. So what I'm going to do is I'm going to do f of 5 here. I'm going to do f of 1 here. You don't have to do it this way. But for the first two, I'm going to do it this way just so that it's easier for you to see. So f of 5 equals negative 10 plus 9. So f of 5 is going to get negative 1. Now if I plug in 1, I'm just replacing the x with 1. So f of 1 is equal to negative 2 plus 9 So f of 1 is equal to 7. So now what I'm going to do is I'm going to take f of 5 minus f of 1. Well, f of 5 was negative 1. I brought that straight down. F of 1 is 7, so minus 7. So my answer to this is negative 8. Okay. So we're going to do the exact same thing, except for this time we're going to plug in a negative 4. So that was weird. F of negative 4 equals negative 3 times negative 4 plus 2. So f of negative 4 equals 12 plus 2. So f of negative 4 is equal to 14. Now, seriously, negative 3x plus 8. Is that right? Nope, plus 2, Kimberly. So f of x, that's what it equals. So I'm going to actually write it like this. And I'm just going to plug it in. Negative 3 times 5 plus 2 plus 8. So all I've done is take this 5 and plug it in there. So f of 5 plus 8. So this is the f of 5 right there, and then we have the plus 8. So this is going to get us negative 15 plus 2 plus 8. So f of 5 plus 8 equals, so that's going to be negative 5. Okay, so on this one, I'm going to take, I don't know why I just rewrote that instead of just writing it here. So this is where you have to be careful. Negative 3 times 3 plus 2. Now this is minus. Well, I'm subtracting this whole thing. I'm not just subtracting one thing. So I'm going to replace with 6. So negative 3 times 6 plus 2. So this is going to get me negative 9 plus 2 minus this quantity, which is negative 18 plus 2. Negative 7 minus negative 16. So, oh, this is not going to be negative. Okay, so that's going to be 9. And I should have written this on the side. And there we go. Okay, so this one has a squared. So we just have to be careful when we're doing this. So I'm going to replace x with 2. H of 2 equals negative 6 times 4 plus 36 plus 36. H of 2 equals negative 24 plus 36 plus 36. So that's going to get me, what, 12 plus 36? Oh, that put H in there, silly child. So 48. So I'm going to write this over here. H of x equals negative 6x squared plus 18x. It's just easier to see. That's why I'm writing it there. Okay, now I'm going to replace with the 4. So negative 6 times 4 squared plus 18 times 4 plus 36, and then I'm going to subtract negative 6 times 1 all squared plus 18 times 1 plus 36. Okay, so h of 4 minus h of 1. So this is going to get me negative 6 times 16 plus, why do I do these numbers that I can't do in my head? 18 times 4, 7, oh, I should have known that. It's okay, minus the quantity, negative 6 plus 18 plus 36. So h of 4 minus h of 1 equals 6 times 16. Negative 96 plus 72 plus 36 minus the quantity. This is 12 plus 36. H of 4 minus h of 1 equals negative 24 plus 36 minus 4, I don't know why I have parentheses anymore, 48. And can I just put that into the calculator as is? Yes. And I'm going to plus 36 minus 48 equals negative 36. Okay. So last but not least, well, for this part. Okay, I'm going to plug in 5. So negative 6, 5 squared, plus 18 times 5, plus 36, minus 7. So h of 5 minus 7 equals negative 6 times 25, plus, oh, I don't know that off the top of my head, 90 plus 36 minus 7. Okay, h of 5 minus 7 equals, oh yeah, definitely should have known that. Okay, and I'm just going to put this into the calculator as is. It's 36 minus 7. Okay, so h of 5 minus 7 equals negative 31. Okay, so we're going to do the exact same thing we did a moment ago, but this time we're going to plug in 2. So 2 times 2 squared minus 8 times 2 minus 10. So g of 2 equals 2 times 4 minus 16 minus 10. G of 2 equals 8 minus 16 minus 10. G of 2 equals negative 8 minus 10. So G of 2 equals negative 18. Okay, so this one, I replace, oops, I'm going to just do it over here. So we have 2 times 5 squared minus 8 times 5 minus 10 plus 12. So G of 5 plus 12 equals 2 times 25 minus 40 minus 10 plus 12. G of 5 plus 12 equals 50 minus 40 minus 10 plus 12. Minus 10 plus 12. Hopefully you can see that that cancels out. And we get 12. Okay, and so G of 8. So 2 times 8 squared minus 8 times 8 minus 10 minus 18. So g of 8 minus 18 equals 2 times 64 minus 64 minus 10 minus 18. And that's going to get me 128 minus 64 minus 10 minus 18. So g of 8 minus 18 equals 64 plus 10 minus 18. 54 minus 18. Oh, and that's going to be 36. Okay, so this one, so 2 times negative 3 squared minus 8 times negative 3 minus 10 minus the quantity of 2 times 4 squared minus, oh, this is going to be tight, 8 times 4 minus 10. Okay, we're going to do a little more scrunching over here. Okay, so this is going to be 2 times 9 plus 24 minus 10 minus the quantity, 2 times 16 minus 32 minus 10. There we go. G of negative 3 minus g of 4 equals 18 plus 24 minus 10 minus the quantity 32 minus 32 minus 10. G of negative 3 minus g of negative 4, or of positive 4, equals 42 minus 10 minus negative 10, which is positive 10. So 42. Okay. Employment. Mason works at the movie theater after school. The function is g of x equals 9.25x represents the amount of money he makes before taxes for each hour that he works. So $9.25 for 1 times 1 hour times 2 hours times 3 hours. So I'm going to replace, and I'm going to do 9.25, and I'm going to multiply that times 8. So g of 8, 9.25 times 8 is going to get me $74. Okay, so if I do this, 9.25 times 14. So if he works 14 hours, he makes $129.50. Okay? If he works 27 and a half hours at $9.25 an hour, and remember, money is only 2 decimal spots, you make $254.38. Okay, so 9.25 times negative 4. He would make negative $37. Okay, does this make any sense? Can you actually work negative 4 hours? You can't. So that negative doesn't make any sense whatsoever. So what's the domain of this? Okay, so what numbers can I plug in for x? Okay, you can plug in 0 hours. Okay, domain. You can plug in any number you want. So this right here is the infinity sign. Really and true, you can't really have infinite, but it's usually 40 hours. So infinite amount of domain. Okay? Range. That's domain. Range. Okay? What's the lowest number of money you can make? 0. And it's also infinite, because if you worked an infinite amount of time, infinite times 9.25 is going to get you infinite. And infinite will always have a, what is it called? A parenthesis and not a bracket. Okay. A swimming pool that holds 10,000 gallons of water is being filled at a rate of 600 gallons per hour. The function h of x, 600x, whoa, that came out weird, represents the amount of water in the pool after x hours. What is the domain and range of the interval? Okay, so let's think of it. Domain is talking about hours. Okay, how many hours can you have? Range is talking about the amount of water. Now, on a normal basis, boys and girls, when you're doing this right here, okay, think about it. Your pool only gets to a certain amount, okay? Your swimming pool only gets to a certain amount. So what I'm going to say is we're not going to talk about interval notation for this because we don't know how. Oh, no, we do. Sorry. It holds 10,000 gallons. So for the range, we would go from 0 to 10,000 gallons. Okay? Now, we don't know. Oh, you know what? We can figure that out. We're going to do domain in just a second because we have to do something else first. Let's do this first. H of x equals 600 times 3.25. So, oops, I didn't mean to write that. Kimberly. Sorry, 3.25. I didn't put in my right information. 3.25. Okay, so 3.25 times 600. It's going to get us 1,950 gallons of water. So what does it mean? It means that at 3 hours, there are 1,950 gallons of water. That's what that means. Sorry about that. Okay. So the next thing I want to look at, which is not on here, but I want to know my domain. So I need to know when this ends. So I want to know when the pool is 10,000 gallons of water. And so what I'm going to do, h of x equals 600x. What we're going to do is we're going to take this and we're going to plug it in here. 10,000 equals 600x. And we're going to solve this and we're going to divide by 600. And it's going to come out to a repeating decimal, but that's okay. We can do approximates. Divided by 600. So 16.67 is the approximate value for x. So my domain is actually this is my domain. It's going to be going from 0 time to 16.6 repeating. That is going to be my domain. That's the highest number that you can plug in order for us to get to 10,000 gallons.